What I want to do now is change the theme of this particular conference. If I can just now, let's see. And discuss, or should I say talk about, myopia control. Why? Because of two reasons. Number one, we are in the business for correcting presbyopia. We are also in the business for correcting myopia. And there seems to be a lot more technology has been pumped into correcting myopia, for correcting presbyopia compared with myopia. In other words, there's a trickle-down effect. All of us in this room have prescribed glasses and such like. Yep. Spectacle technology had actually started in the 13th century. Some of you may disagree. I'm sure that there are some areas of the world, for example in Southeast Asia, which will disagree that maybe they invented glasses. In India, we invented everything. In Europe, which always regards itself as the cradle, Europe will claim that they invented glasses in the 13th century. But the point is, we are still using them, so am I, and so are we on a worldwide level. If we want to progress, we need to do something new. But why bother? Well, the reason why we need to bother is myopia is on the rise. You will hear phrases such as myopia has reached epidemic proportions, giving it the impression that it's like a disease that kills. It doesn't kill, but it is a problem. How much will myopia increase by? Well, simple calculation shows that at the moment, myopia in some territories is certainly rising, and in some regions, 70 to 90% of children will be myopic. In other words, myopia is becoming the normal. Myopia is becoming the new, this is the way to be. Okay? But is that the case? Well, the answer is no. There's lots of techniques for correcting myopia and slowing down its progression. You cannot get rid of myopia, but at least as professionals we can slow it down. And techniques such as atropine has been used, bifocal glasses, drug treatments, contact lenses. All of the techniques have been tried, and there's quite a few publications out there. And I tell you now, if you look at some of the publications, they are what I call effect of studies. How many studies have you read, publications that started with the title, The Effect of, fill in the blank space? A lot of these publications in myopia control are more like effect of publications. I'm not saying they are bad, I'm just saying that's what they are. They've got into this trend. So we really need to start to develop something new, a new idea, a new way of thinking of how we can control myopia. Why do we want to control it? Because how many of you have children? Yeah, majority of you have children. Would you be happy if your child was myopic? Would you be happy that your child remained at -1? Or would you be happy if they were -7? Your choice. I think I can guess what you will prefer. I think you would prefer -1. I haven't got rid of it, but I've controlled it. So let's see how we can control it.
Sudi, can you ask how many people use the atropine here in the...
I will ask. How many people in this room are using atropine to control myopia? A minority. 3 hands have gone up.
It's working.
Okay? It's working. If you do it right.
How long is your experience?
Well, less than 1 year. But with all the children, there are 2 or 3 good papers which show that.
How concentration? 0.01.
0.0, yeah, 5 or 1, I don't remember. I can't
One.
remember. 1, that's right, that's all, sorry.
Start with one and
It's a very low
Low
doses.
density, yeah,
Low
low
density.
dose.
Now,
Only
can we-
one drop per day or two times? Or?
But there is a big argument they use the atropine in China. Argument. It's like both, sides. Conflict.
That's right.
It's at
In
night.
some
Night
territories,
time,
I can tell you now,
Exactly.
in the UK, nobody's using atropine. So it's not happening, okay? But the point I wanted to make is atropine is there, so are contact lenses. And the reason why I'm promoting contact lenses will be more apparent in a moment or two. Contact lenses have been tried for myopia control, but there's a lot of controversy of how useful it has come about. Some people are saying that you can drop the progression from control groups where it's about 1 diopter per year down to 1/10 of a diopter per year. But it depends all down to the design of the contact lens. Excuse me. The one thing we do know is that peripheral defocus, as shown by this slide here, is an important feature when it comes to myopia progression. With spectacle lenses and ordinary contact lenses and the such like, we have this defocus which causes the periphery of the retina to grow outwards and the central part too, leading to myopia progression. So if we can somehow control this peripheral defocus in a nice way, then we can actually reduce the rate of myopia progression. Now that is taking into account the peripheral vision. Atropine, what does atropine do? It just paralyzes or reduces accommodation. Atropine does not really change peripheral defocus at all. So even though atropine drops have been claimed to reduce the rate of myopia progression by controlling accommodation, what you are doing is attempting to control something that you don't understand fully, because David and people like him are still looking at that aspect, which is accommodation. So we're using drops to control something that we actually don't fully yet understand. When it comes to peripheral defocus, that is something we do understand. We do.
Well,
And therefore we can control it. If
the
you...
low dose doesn't block accommodation.
Sorry?
The low dose 0.01 doesn't block so much accommodation.
What does it do?
It blocks some intraretinal signaling that signal the elongation of the eye because of the defocus. It blocks some neural connections.
It hasn't changed the peripheral defocus.
No, but it blocks the signal that says you need to grow the eye.
It's not yet scientific.
Of course
Yeah,
not.
it's
Of
just
course
the
not.
theory.
It's just one of the
It's a
theory.
theory, of course.
It's a theory. It's like when I look in the mirror, I know that I am not bald. I know I am not bald because my mirror does not show me that I'm bald. It's a theory.
Of course.
It might be right. It might be wrong. The point is, what we do know is peripheral defocus, and that is something we can control. So, we've developed a particular contact lens. I'm not going to go into it in more depth, because that is more on the commercial side, but does it work? Well, these two graphs show that off-the-shelf spherical contact lenses from -3 gives us a certain degree of wavefront aberration. -6 gives us a wavefront aberration. But look how different these two are, and it's in two different eyes. Different eyes, different lens powers, same design of contact lens. So there's a lot of variation between one eye and another. What we can do is to try and average things out. In design, you average things out. When you buy a suit off the shelf, it's an averaged out. It isn't perfect, but it's better than walking around naked in the country where people are not blind. We're averaging things out. What this slide shows here is by changing the design of the contact lens, we can change our wavefront aberrations from position A, which we've got here, to position B, which we have here. In other words, by carefully manipulating the design of the contact lens surface in relation to its back surface, in relation to its hydration characteristics and the rest of the eye, we can get a wavefront aberration which is more like the one we want to control peripheral defocus. Will this change near vision and distance vision? Well, this slide summarizes very quickly the acuities, best corrected visual acuities at distance with an off-the-shelf lens compared with the product we have, which we call MyoLens 2. Distance and near, MyoLens 2 seems to be working. I didn't collect the data. I was just involved in developing the lens. Somebody else collected the data on a, randomized masked way using -6 lenses. It's all very well. Low power lenses. What about higher power lenses? Do they do the job? Well, so far, it appears the answer is yes. Visual acuities are better, distance and near. What about depth of field? Because depth of field will be affected by these designs of contact lenses. If we increase the depth of field, that's good, because that will try and mimic, to some extent, what atropine is doing, reducing the need to accommodate, because this contact lens has given you that extra field of vision. With this particular product, our depth of field at distance and at near is better than with an off-the-shelf ordinary contact lens. So we managed to do two things with this product. One intentionally, the second by accident. Intentionally, we have changed the wavefront aberration. Unintentionally, which is a positive benefit, we increased the depth of field. So we've killed two birds with one stone with this design. We've improved depth of field, we've improved we've better controlled peripheral defocus. So in summary, you have patients who are myopic. That group of patients is going to increase. What you can say to the parents of those children who are myopic, your child is -1, -2. But we can control it. Why? Because we have the technology. Thank you very much for your attention. And I will now